as a student. I'm starting. So, one of the things that I think that makes students much better students, especially in mathematics, is understanding what it is they're supposed to be doing, right? What's the biggest problem that you had when you were doing that last assessment? Do I need to do area here? Do I need to do perimeter, right? Knowing when you need to do what, yeah? And that's going to be the biggest challenge you'll have in all of mathematics, is knowing when to do what, okay? Well, today, we're going to begin our first look at algebra. Now, algebra, and then we'll talk about what that means and what it entails, and we're actually going to begin by doing something that you've already done, right? So it's not really very much algebra involved today. But one of the things that I think that students don't do is they don't take very good notes. Think about this. If you were going to do something, say you're going to, put together a toy of some sort, right? It's got all these little parts that are all taken apart. Would it be easier to learn how to do that by simply watching somebody do it really quick who knows what they're doing? Or by having a set of directions that you know that you can make sense to you, so you can say, okay, step 1, I need to do this. Then do that. Step 2, I need to do this. Step 3, I need to do this. Which would be the easiest way? Yeah, to have all the steps, right? And so what you can do as a student is you can start learning how to develop those steps. Now, the good news is, as a teacher, I'm going to give them to you for the problems. But then it's your job to make sure that you have them and that you make sure that you can bring them back later, right? Because we all knew what a triangle was, yeah? No. Did we always know what formula to use and when to use it? And each piece, remember, I was there. Okay, so that's the kind of thing that we want to focus on. And the way to do that is to take notes. Now, lots of research has been done to show that taking notes on paper with a pencil or a pen is better than typing in your notes. And especially in math, because you have lots of symbols and things. Now, if you're really good at that, then it's no big deal. But taking notes with a pencil and paper is far superior. Okay? So, would really like for y'all to give that a try. If you hate it or you have trouble writing with it, then that's totally different, because we're going to be recording all these anyway.
So we don't need people on their laptops right now.
Right. So there shouldn't be any reason to have your laptop out right now. Okay? All right. Plenty of time for that later. Okay. So let me show you what I mean by taking. So you're going to be taking notes, and those notes should include all of the steps, the process. Now, I couldn't possibly write out a series of steps for every single problem you're ever going to see, right? But if you've done something for a while and you get good at it, can you do something that's similar without too much trouble? Mm-hmm. So if you focus on getting that process right, then you can expand it and move forward and do other things, right? It makes perfect sense. You've been doing this a lot, haven't you? So that's what we're gonna look at, and the way we're gonna concentrate on things, right? And if you develop good habits now, while you're still young and your minds are all fresh and not full, then you'll be in good shape to keep going later. Okay? Does that sound better, scary, worse? Am I frightening you? I don't want to. Okay. All right, so what we're going to do today is we're going to be looking at the beginning of our algebra section. It's the very last section that we'll be working on. We'll be working on it for the end of this term, and then all through term 4 before the end of the year. Sorry, I keep saying semester because we had semesters back in the States. So we're going to concentrate on doing this, taking good notes and doing steps. And I'm always going to model that behavior for you so that you can see what I mean by taking good notes and steps. And I'm even going to show you a process that I like. You don't have to use it, but I like it. You might want to give it a try. That makes your notes more organized and be easier to read. Okay? And so we're going to try that as we go. So, all right. But notes are no good if you don't actually hold on to them and bring them to class with you. Okay? Because what I'm going to do is I need to know how much you know. So I'm going to ask questions from the notes. For example, if we were learning about a problem and I just wrote down some problem like this, very simple, and I said, okay, so what operation do we have here? And you would say, what operation does that indicate? Addition. And I'm adding how many numbers? Two numbers. And so that means I just need to put them together, right? So 2 plus 3 is going to make 5. Do you see how I'm just walked you right through the process? And that's the way we need to think when we're learning how to really dive into being able to do problem solving, right? Really think about what it is you're going to do, and don't do what we normally do, which is, okay, I think I need to get this done as quickly as possible, right? So just stop slowly and think about what it is you're being asked to do, and then perform the operations. Okay? So take it slowly and carefully. Yes, ma'am.
What was the plus word that you just used?
Addition. So, yeah.
No, the one, you know how you said like down and then down, and then if you plus.
Oh, added to? Maybe? I can't remember.
You know the.
So when I said combine, maybe I said combine, I'm not sure. We'll have to see.
Okay.
Yeah. And
at least you have a recording.
You bet. You can always tell me later. So, and also always remember too that if I use a word you don't understand, please do ask, and I'll try to remember, because some things are different. Like for multiplication, y'all say times, right? And I always say multiply. So I would rather learn what you say, because you're not always going to have me in class, right? So you might have another teacher. So you want to make sure that I'm doing it so that you can understand the language they use. Okay? So. Okay. You might write this down. Yeah, that couldn't hurt. Okay. Okay, so I said that we're going to be starting in algebra, but when we talk about algebra, we're going to begin talking about algebra by looking at some number patterns and sequences. Okay, so patterns, and we're used to patterns. You've seen lots of patterns in mathematics, right? So just the plain counting numbers are a pattern. Each number is how much bigger than the one before it? One number, right? Now, have you seen these 3 dots at the end before? Sure. What does that mean it does? Yes, it means it goes on like that forever. So it's the same as the word etc. Etc. means continue in exactly the same pattern, right? So you're continuing in the same pattern. There's some other patterns that you're very familiar with. Anybody know what I'm writing here? Even numbers. There you go. And even numbers, how far apart are even numbers?
2.
2 units apart, right? So if you start with 2, add 2 to get the next one, add 2 to get the next one, etc. Now here's one. Be careful. What kind of numbers are these? The odd numbers. And how far apart are odd numbers? They're also 2 units apart, right? So the pattern here is add 1 every time. The pattern here is to add 2. The pattern here is also to add 2. Even though they're odd numbers, they're still 2 units apart. Yes, forgot one, didn't I?
Wouldn't 2 also count as an odd number? Because it's only divisible by 1 itself.
Well, no, because when you think about numbers like that, it's divisible by 1 in itself. That's something called prime, right? But it's the only even prime number, but it's prime. So prime numbers mean that numbers that can only be divisible by 1 in itself, right? But every other but an even number, the definition of an even number is any number that's divisible by what? 2. And isn't 2 divided by itself 2? Won't 2 divided by itself? Yes. So there you go. Okay. Now, All right, so you've seen some patterns. Some patterns you know, and you know them really well. What we're going to do is we're going to be looking at some patterns today that aren't so familiar. They're not just patterns of odd numbers, even numbers, things that we use. They're just patterns that happen to arise from a situation or that the book will give you or something like that. Okay? So let's go back to that textbook and look at this. So to improve their fitness, Sari and Tim decide to run 5 kilometers every 4th day in March. So are they running every day? No, they're going to be running every what? 4th day. Okay? So pay close attention to any information that they give you about when something is happening, right? Because that's going to establish the, what do you think it's called? The pattern. There you go. It's every 4 days, right? Okay. Starting on what? March 1st. Good. Okay. So if you start on March 1st, then what we're going to do is we want to write down the days on the calendar as they go, right? So if they start on the 1st, then they're not going to run again until how many days later? 4 days later, right? So that's the same as saying, what operation do you think? 4 later is going to be plus 4. So there's our pattern that we're going to have. So what is 1 plus 4 going to make? 5. And then we add 4 to that and get what? 9. And you can see they've already written down the list here, but doing it and writing it yourself is better for learning, right? And after that, 9 plus 4 is going to give us 13 first, right? And then 17, 21, 25, and 29. Now notice they didn't say ... Can anybody tell me why they didn't use ...
Because there's only 30 or 31 days in a month.
Exactly. So they only said they're going to do this for March, right? So they're only going to be running in March, and they're just not, that March doesn't go on forever, does it? Now, they may run for another month, but here they were only talking about looking at March. Okay? How does that look for a pattern? Okay? Doesn't follow evens, odds, whatever, but it's easy to see what the pattern is going to be. And in this case, we were increasing the number of days. Okay? So let's look at that word for a minute. I want you to write down the word increasing and think about what it means. If something is increasing, it's getting what? Bigger, right? So our number is getting bigger, and what operation do we use to indicate increasing? Sure.
Addition or multiplication.
Right, and we're going to start by just saying addition because we'll talk about multiplication in just a moment. So addition. If you'll remember that multiplication is just addition, but you're adding the same number over and over and over and over, right? So 3 times 4 is the same as 3 added together 4 times, right? So multiplication is really just repeated addition. And so if you're doing something with the same number over and over and over and over again, then we could also use multiplication to increase. But in this case, I started with 1, but I was increasing it by what? Right? And so that kind of increase is going to be addition because we're not starting with the same number we started with. Now let's say we started on the 4th, and then we were going to go 4 more days later, and then 4 more days later, and then 4 more days later. We started with a 4, and we're increasing it by what? 4 every time, right? Okay? So we could think about multiplication then if it's the same number over and over, and we're certainly going to have some of those. Okay? Now, the next word I want you to think about is the word decreasing. What does the word decreasing mean? They're getting smaller, right? So if a number is getting smaller, just thinking about the opposite of addition, what is the opposite of addition? Subtraction, exactly. Okay? Right. And if you were doing subtraction over and over and over and over and over by the same number, you would use division, the opposite of multiplication. Okay? So, but right now we're going to concentrate mainly on addition or subtraction, and then we'll talk a little bit about what happens when we start with multiplication patterns. Okay? All right. Excellent. So, here we've got some patterns in our example 1. There they're talking about increasing means getting larger and decreasing means getting smaller. And usually that means addition or subtraction, but there can be times when increasing or decreasing means division and multiplication. We'll talk about those. So let's look at some of these sequences and talk about what's happening. So in this first one, in 1a, it says we're going to start, we're going to start at 8. Okay? So do I care about any of the numbers before 8? No. My list is going to start with the number 8. And they always need to give you some starting point. Okay? And then it's going to increase by what? 3 each time. So if I take 8, the next number is 8 plus 3, or what? 11. There you go. The next number would be 8 plus 3 again, which would be what? 14. Excellent. So the next one would be 8 plus 3 plus 3 plus 3, which is, I broke it.
Then 20, and then 23, and then 26, and then 29, and then...
Exactly. So you see what they're doing is they're just writing out the pattern so that you can see the pattern and how it builds, right? But in reality, if you know the previous number, what can you do? Just add 3 to it and get the next one, right? And so on forever. Now, notice here, they did say ... etc. Why is that? Goes on forever. They didn't tell you just to stop at a certain number, right? Just go on until you can't go on anymore. Could you write them forever? Could you ever write down all of them?
Yes. No. Yeah. No. It's impossible.
It's impossible because how many numbers are there?
Infinite.
An infinite number. Yeah, so we could never be able to write them all down. You could sit here for the rest of your life and you could never write them all down because you could always add 3 again, right? Okay, good job. Okay, so let's look at the next pattern. The next pattern, they're talking about decreasing them. So they start with the number 108, and then they're decreasing every time by 7, right? So we start with the number 108, and then from that we subtract 7 to get 1. From that we subtract 7 to get what? 94. Okay, I'm cheating and you can too. They gave you a list here. Okay, but you can use your calculator to do these, right? To do the subtraction, or you can just do the subtraction. Subtracting 7 is not too difficult. Okay, so you see that you can establish a pattern, and a pattern simply means that it continues on in the same way, right? So, excellent. So what we're going to do is we're going to look at exercise 11a, and we're just going to do a few of these and look to see what they would be. Now, here's what I want to do is I'm going to give each table one of the patterns. So you're not all going to be working on the same thing. Okay, so this time they're going to give us a set of numbers, and we're going to see if we can find out what is the rule that they're using. Okay? Now let's do A together, and then I'll let you all of us, the rest of you do B. Slow down because I know y'all already have the answer here. So first thing we need is we need to know where to start. Okay? So I'm going to do the first one together so I'm not so worried about it. All right. There we go. Okay? So we need to know where to start. What other piece of information is really important? What do we need to do? Exactly. So they also need to know, are we increasing or decreasing? Can we do both at the same time? No, not in these patterns. But we need one or the other. Okay? And there's one more piece of information we need to know. What do you think?
How much you are increasing or decreasing?
Exactly. How much we're increasing or decreasing each number. So by 2, by 7, by whatever. Okay? So we need to know the amount to increase or decrease. One or the other. Okay? All right? Is everybody happy with that? So, if I were going to describe the pattern for this first one here, what number are we starting with in that pattern? 6. So the number, it starts with 6. The next number is 10. Okay? So does that mean it's getting bigger or smaller? Bigger. So we're going to start, sorry, I didn't write that down, did I? Start with 6, right? Okay. And then we're getting bigger, so that means we're going to be doing what? Increasing. Now we need to determine how to do that. And the best way to do that, yes, go ahead. Okay, well, so if you think about, if you're going to find addition, we can usually find things by doing the opposite way. So if we're increasing, which means add, how can we then find out what number we're increasing by? What's the opposite of add?
Well, you could go to 10 minus 6.
Exactly, we can do subtraction. And it's called the rule of differences. Where you can just subtract and see. And to make sure you've got the same pattern, you have to be subtracting and get the same number over and over and over again. Okay? So, we have 10 minus 6, which gives us what? 4. Then the next ones are 10 and 14. Well, 14 minus 10 is what? 4. It's 4, isn't it? Okay, there you go. You know, I'm going to check. Then the next ones are 18. 18 minus 14 is what?
2. What?
Yeah, 4. All right. Wait a minute. Y'all are starting to do math like me. That worries me a little bit. Okay. All right. So what do you notice? What's happening here? Right, we're getting 4 every time we do this. We do the difference of it. So that means that the number we're increasing by is 4. Do you see the logic there? If you subtract take the difference between each one of them, and you get the same number and over and over. Now, what if the next number was 20 and the number before that was 14? What's 20 minus 14?
6.
Does that fit our pattern? So that tells us, now I just made that up, so it doesn't exist, right? But it tells us that we don't have the right pattern, does it? So that's what you can learn. As long as you take the difference between each one and they all come out the same, then you know you've got the right pattern. Okay? If you take the difference and then they start coming out different, then you know you're going to need some different pattern. Okay? But these are going to come out even. All right. So we start with 6 and increase by 4. And there's one more word I want to point out here. What's that? Mm-hmm. Yeah, it's so forever, right? So there's no end. And this does say that. It doesn't give it any boundaries, right? It doesn't say stopping at 50 or less than 100 or something like that. So that's how you know that you'll have to put in that etc. or those dots, right? Okay, so let me get rid of some of this stuff because I've made a really big mess up here. And I want you guys to do B, okay? I'm going to give you just a few minutes. You can work as a group or you can do it independently and then have your group check. But go, do B. Do that one, that sequence. Find the pattern. Mm-hmm. So you write down the pattern, the rule for the pattern, okay? Yes. Okay. All right, can you see it? 39, 37, 35, 33, 31, etc. So we want to do our pattern. So what are the pieces that I need? So what's the very first thing I need?
Start and
Yeah, I've got to have someplace to start, right? Okay, there you go. So you have the right pattern. It is definitely decreasing by 2. But what number did we start with? Anybody? 39. Okay, so in words you should write start with 39. I shouldn't abbreviate like that. Let me just fix that. Start with 39. Okay, and is it increasing or decreasing? Decreasing. And you're going to decrease by what? Decrease by 2. Does it have an end?
No.
Pardon? Okay. What's your name?